Whether you have found a way to love them or not, spiders are pretty creepy. It's not just their size or speed, it's how alien they are compared to any other animal. Unlike insects, spiders don't have an actual head. Instead, their body and head merge into a single, eerie structure called the cephalothorax. And if you think spiders are closely related to insects, think again. Spiders and insects split from a common ancestor over 500 million years ago, making humans and sharks seem like family by comparison. But why are spiders so unlike anything else in the animal kingdom? What is behind the alien design of spiders, and what ancient creatures share their DNA? Spiders are full of surprises, with an astonishing variety from one species to another. Some are incredible engineers, while others are great at camouflage. There are amazing acrobats among them, and some even show signs of intelligence we've only just begun to understand. It's fascinating how spiders use the same tools in countless ways to catch prey and navigate their world, and yet they're all still spiders. But to truly grasp the incredible diversity of spiders, how they differ from insects, and how their ocean ancestors evolved to conquer the land, we need to establish some important context. Spiders and arachnids actually trace their roots back to some really fascinating marine ancestors, and their evolutionary journey starts about 500 million years ago with a small creature called Mollisonia planovenatrix. This little creature, no larger than your thumb, lived in a time when most creatures were similarly small. Despite its size, it was probably a tough predator, armed with sharp, pointy appendages designed for hunting and feeding. The most important of these were the tiny claws just above its mouth, known as chelicerae. These appendages would later evolve into the fangs we associate with spiders, though they're not exactly fangs at all. Rather, they're a highly modified form of arthropod limb. Mollisonia planovenatrix is considered the common ancestor of the chelicerata, a group of animals defined by their mouth parts. The chelicerata belong to the larger arthropod family, which includes arachnids and their marine relatives. Some of these ancient sea creatures, like horseshoe crabs and sea spiders, still roam the oceans today, while others, like Mollisonia, are long gone. One notable group that emerged from this line was Eurypterus, or sea scorpions. Around 410 million years ago, Eurypterus ruled the seas as the top predator. They even gave rise to the Jackalopterus, a giant arthropod that could grow up to 2.5 meters in length. Though they were often called sea scorpions, Eurypterus weren't closely related to the scorpions we know today. In reality, spiders, scorpions, and all arachnids share an equally close relationship with these ancient sea creatures. Scorpions are often seen as more primitive than other arachnids, and this is because they've preserved many traits from their ancient ancestors, giving them a closer resemblance to the sea scorpions that once ruled the oceans. Eventually, arachnids made their way onto land, but the exact timing and process of this migration remain debated. Unlike land vertebrates, which all evolved from a single lineage that adapted to life on dry land, arthropods have many different evolutionary origins. It's even uncertain whether arachnids all came from the same event or series of events when they transitioned from water to land. Arachnids are divided into two main subgroups. One includes spiders and ticks, while the other includes scorpions, along with some of their less pleasant relatives like sun spiders, also known as camel spiders. Some researchers argue that these two groups might have evolved from distinct lineages, possibly even leaving the water at different times. Are scorpions and spiders related? Scorpions, interestingly, are much older than spiders. In fact, they are among the earliest land-dwelling creatures, with the oldest confirmed scorpion fossils dating back around 430 million years. These early scorpions lived long before any vertebrates made their way onto land. The world they inhabited would have looked almost alien to us. There were no trees, and the moon was much closer to Earth, appearing about 10% larger in the sky. The landscape was dotted with small plants, and tiny animals roamed the land. It wasn't until around 410 million years ago that the first ancestors of spiders appeared, though they weren't direct ancestors. These early arachnids, known as Trigonotarbia, were part of the spider family tree but branched off early on. They were one of the first arachnid groups to make the successful transition onto land. This period marked a critical point in the evolution of arachnids, as creatures began to adapt to life outside the water. Some of these early arachnids resembled ticks, while others looked more like spiders, yet they all retained some primitive features from their ancient relatives. By 400 million years ago, the lineage of scorpions and spiders had definitely split. What's fascinating is that there were other scorpions coexisting at the time that had feather-like structures that likely functioned as gills. This suggested they were at least partially adapted to living in water, leading some researchers to propose that scorpions might have evolved from their own aquatic ancestors. Arachnids breathe in a pretty unique way compared to insects. Instead of simply diffusing oxygen through their bodies via openings, spiders have a specialized organ called book lungs for extracting oxygen from the air. These book lungs consist of several layers of tissue that look a bit like the pages of a book, and they work to absorb oxygen. They function similarly to gills, but they don't require air to be pumped around, and most species don't need any movement from the plates for them to work. The design increases the surface area available for oxygen absorption, which is pretty neat. This breathing structure might suggest that all arachnids share a common land-based ancestor, especially since they evolved similar breathing mechanisms after leaving the oceans. However, scorpions have 8 book lungs, while spiders have only 2, and their structures and placements differ significantly. That said, detailed studies of the book lungs in spiders, scorpions, and other arachnid groups have revealed some interesting similarities, hinting that they might have inherited this trait from a shared ancestor. Interestingly, some of these ancient scorpions believed to be aquatic might have adapted back to living underwater after evolving from land-dwelling relatives. The idea of secondary adaptation is fascinating. It suggests that these creatures have had a dynamic evolutionary history, bouncing back and forth between land and water environments over time. Hey guys, just a moment. If you're enjoying the video, give it a thumbs up, subscribe, and make sure to hit that bell icon. Now, let's check out some of the weird yet fascinating attributes of spiders. We'll begin with spider silk, which is one of nature's most incredible creations. Unlike web-building spiders today, the earliest arachnids couldn't spin complex webs. Instead, they produced primitive silk, likely used for egg sacs or lining burrows. The silk itself isn't just one material, it's a family of proteins with varying properties. Some silks are sticky, others stretchy, and some are stronger than steel by weight. The ancestors of spiders might have used silk defensively at first, creating barriers or escape lines. Over millions of years, this silk was refined into a tool for trapping prey, with orb-weaving spiders leading the evolutionary charge. But here's where things get eerie. Some spiders don't even use webs to catch prey. Jumping spiders produce silk lifelines, while bolus spiders mimic moth pheromones, luring unsuspecting victims into a single strand of deadly silk. Fun fact, spider silk can self-heal at a microscopic level and remains functional in extreme conditions, from freezing temperatures to scorching heat. Even now, silk holds secrets. Some spiders can produce up to 7 different types of silk, each tailored for a specific purpose. If you're not impressed yet, wait until you hear about spider venom. Firstly, not all spiders have venom, but the ones that do have turned it into a weapon of horrifying precision. From paralyzing prey to liquefying insides, venom gives spiders an edge unmatched by most predators. But why did venom evolve in the first place? Early arachnids like Molossonia planovenatrix had pincers but no fangs, suggesting they relied on brute force to subdue their prey. Somewhere along the evolutionary line, those pincers became chelicerae, capable of delivering venom. The transformation likely began as a way to warn off predators or break down tough prey. But over millions of years, spiders refine their venom into a deadly cocktail tailored for survival. What makes spider venom so eerie is its complexity. Black widow venom targets the nervous system, tarantula venom causes severe pain, and spitting spiders use venom to glue prey in place. It's as if evolution equipped each spider with a custom toolkit for terror. And then there are these strange outliers, like the net-casting spider, which uses a web laced with venom to ensnare victims. Even more unsettling is the venom's adaptability. Some spiders, like recluse spiders, produce necrotic venom that can destroy tissue, while others can switch their venom composition depending on the size and type of prey. Spider eyes are more unsettling than most people realize. Unlike insects whose compound eyes provide a mosaic view of the world, spiders have camera-like eyes with lenses and retinas closer to human eyes than you'd think. But what they do with their vision is downright eerie. Jumping spiders, for instance, have some of the sharpest eyesight in the animal kingdom, despite their tiny size. Their principal eyes can swivel independently, tracking prey with unnerving precision. Unlike us, they don't rely solely on visual focus. They use layers of lenses to detect depth, allowing them to gauge distance for a perfect ambush. Even stranger are wolf spiders, which can see in near total darkness. Their eyes are lined with a reflective layer called a tapetum, which bounces light back through the retina. This gives them the signature glowing eyes you might spot at night. But why develop such an adaptation? Was it to hunt in moonlit forests, or was it a defensive measure against nocturnal predators? Adding to the mystery are orb weavers, whose vision is notoriously poor. Instead of relying on sight, they feel vibrations in their webs to detect prey. Then there are spiders like net casters, whose large, forward-facing eyes give them an otherworldly appearance. These specialized arachnids can hunt in pitch-black conditions, aiming their web traps with uncanny accuracy. Scorpions and spiders also have a pretty cool and unique way of moving. Unlike insects, which use muscles to operate their legs, spiders rely on a hydraulic system. They have muscles mainly for curling their legs inward, but to extend their legs outward, they pump blood into them, creating pressure that pushes the limbs out. This hydraulic movement gives spiders a crawl that often feels eerier compared to the more straightforward motion of insects. One of the oldest close relatives of modern spiders is Anacarpus, found in the mountains of New York. This ancient creature was about 1 centimeter long and had a segmented abdomen, which looks a lot like those found in scorpions and other primitive arachnids. Over time, those segments fused together, leading to the smooth, singular abdomen we associate with most spiders today. Interestingly, some primitive trapdoor spiders still have segmented abdomens, having branched off from other spiders earlier in their evolutionary journey. Anacarpus even had a tail, which is a feature seen in various spider-like fossils from that time. This suggests that the ancestors of spiders probably had tails too, but they eventually lost them. In Myanmar, there's an incredible fossil deposit of small creatures, including spiders, perfectly preserved in amber, dating back over 100 million years to the time of the dinosaurs. Among these fossils is a spider with a tail called Chimera arachne, showing that these more primitive forms managed to survive for quite a while before going extinct. Even though spiders often get lumped in with other bugs, most people know they belong to a different category altogether. However, the extent of their differences from other arthropods is something not fully appreciated. Strangely enough, almost every unique feature that makes spiders different from insects seemed to add to their creepiness. And that's a wrap. What do you find most fascinating about spiders? Which small creature do you think will give spiders a run for their money? Feel free to leave your answers in the comments below. If you liked the video, then you should check out the one on your screen. This video on the giant insects of the Carboniferous era will blow your mind. Thanks for watching.